I wasn't going to quite cover that. Let's talk about how they're designed. So I imagine most of you know me by now. If there's something you like about Prometheus, there's a good chance I had my hand in it. If there's something you don't like about Prometheus, uh, so client libraries they're the core there of what actually generates these metrics that Prometheus and then everyone else uses. We've been building them, myself and many others, like they existed before I was involved with Prometheus, which was about 4 years ago. But by now we have a pretty good idea of how to design a client library, what it should look like. We haven't figured out every single detail of what they should look like, but we have most of the main stuff figured out. So we're going to dig into that a bit more. So there's this notion that I call direct instrumentation, and I think by now everyone else has figured out what I mean by that. But that is where you're using the counter type, the gauge type, the histogram and summary type, the objects coming from a client library directly in your application code. You're instantiating them, you're using them directly. This is against something called custom collectors, which is basically an exporter, where it's pulling it from some other monitoring system or some other instrumentation system. So in the ideal world, everyone is using direct instrumentation. We do not live in an ideal world, because we end up with things like the SNMP exporter, which I maintain. Great fun. But one principle we have then is, okay, here we have yet another instrumentation client, one of the at least 20 that are out there. What makes this one different, other than the fact that it has the word Prometheus in the name? So one of the principles we have is that instrumentation should be as easy as possible. Right? You want to get instrumentation out of the way so you can actually implement your business logic, because let's be honest, most of us, our job is not to write instrumentation, it's to do something else that gives us money. Most of your metrics there will not have labels. Now, most of your time series will. That's called the cardinality explosion. However, most of your metrics don't. So you should make simple things simple, and being able to just sprinkle metrics without labels across your code base should be trivial. So here we have a simple example of a counter called myFailuresTotal, which has some description. We put it in an object called fails, all capital because I happen to use Python for this example, and we increment it. And then we've got this, normally this metric definition would be at the file or class level, depending on your language. And then you do the increment in your actual code that runs, during runtime. So, looks nice and simple. Things to note, slide 1. So what it did there is we created a counter, kept the reference to its memory address, so there's a counter object there, and then later we used that reference to call a method on it using presumably a virtual lookup table or however Python's implemented internally. What we don't do is go prometheus.inc, my counter name, and then the value. So there are instrumentation libraries out there that do this. Now, the reason why we don't do this is that it's slower. Because if I'm passing a metric name, I now need to look that up in some form of thread-safe map to find the object to then increment it. Which is, it's going to cost you 30 nanoseconds at least. And a normal instrumentation event is 10, 12 nanoseconds. Not in Python, unfortunately, because Python mutexes are slow. They take a microsecond. But anyway, in Java and Go, it's much faster. The second thing is that if you have this sort of pattern where you're passing in that name rather than just having the reference already, it kind of encourages having the same metric name in different files. Now, there are cases, extremely rare, like I came across 2 ever, I think, where it is okay to have the same metric name in different files. But by and large, different file, different metric name. Because any metric name you have is fundamentally linking back to a piece of code in a file. So how can I refer to 2 different files with 2 different sets of logic and semantics and implications? Another advantage of the Prometheus approach is, let's say that whatever bit of code, this was some weird error path that is never meant to happen. Because, it's good to have some form of instrumentation, whether it be a log line or a metric or something, saying, hey, this weird thing that never meant to happen, it happened. If you have a Prometheus approach, we can say, hey, this metric has been instantiated, we'll set it to 0, so we know it exists. With the other approach, when you only learn about the existence of the metric when you increment it, that doesn't happen, and that's difficult to deal with in PromQL in general, because you don't know what metrics do and don't exist. You can't graph something if you don't know its name. At least it's something later on, Grafana can do something fancy with it. Yep. There we go. Another thing that I showed in my example, for some reason I was incrementing my failure count by 4. which is nonsensical normally because it's one at a time, but I needed an example. So Prometheus, it's all float64s internally. So it means our counters can track things other than, hey, how many errors we can have. We can say, hey, how many records did I just process? How many bytes was it? How long did this take? So you can track more than just a thing happened, a thing happened, a thing happened. And we say, a thing happened and it took 20 seconds to process 4 records. So we can get more information into the system. Now the other thing is those 2 lines of code, which you can see again there, that's everything. There is no more code required for instrumentation. You don't have to implement any threading or concurrency or bookkeeping. It's all taken care of for you. So it's just 2 lines plus probably an import to get everything working. So those 2 lines, they have a lot of details in there. Like 5 different aspects in just 2 lines of code. Now, in addition to the counter, there's also the gauge and the summary. Internally, all of these are just a set of floating point numbers. And there's an asterisk there. And we just adjust these numbers up or down or set them. Okay? Something that people get confused by often is that Prometheus internally is not remembering every single increment you made. It doesn't buffering things up in memory because this is not an event-based system, it's a metrics-based system. So increment basically looks like that. We take the current value and we add on to it. That's all that's to increment. Plus thread safety, plus making sure the value is 0 or larger. In terms of the summary, like the gauge is a single floating point number, nice and simple. The summary is 2 counters and potentially client-side quantiles, which are complicated and I'm not going to touch. The histogram is 2 counters plus a counter per bucket, so it's just a big pile of counters and gauges, basically, for everything. One thing to watch, the histogram exhibition format, it is cumulative. The LE stands for less than or equal to. But in memory, we keep it non-cumulative, except in Ruby, just to reduce contention. So that can confuse many people. It's like, it's meant to be cumulative, but it's not in the code. It's like, yeah, but we switch it over here. Implementation details, and one of the downsides of our choice of how we make histograms work with our constraints is that the buckets must be pre-chosen. People don't like that, but it makes sense for reasons. We've got constraints. There's other designs out there, like Wavefront of an interesting design, for example. Interesting isn't good, to be clear. Now, something that's different, because I've looked at a whole pile of instrumentation libraries out there, mostly to figure out how do we get data from this instrumentation system into Prometheus or vice versa. And like one of the most popular libraries out there is DropWizard, and it has a whole pile of derivatives in all sorts of languages. So an interesting thing, like the way I view DropWizard, is that its metrics types are defined by the API they offer, not the actual semantics when it actually lands inside the database. So in DropWizard, a counter can be incremented or decremented by 1. That's all you can do with it. And a gauge is something that has a callback that you then have to implement all your thread safety for. In Prometheus, both of those are gauges because, well, it's a thing that can go up and down. Because we think about, hey, gauges go up and down, counters we care about how fast they're increasing. So there's that kind of mismatch there of just what we say metric type, whether we're talking about the API that we're using, or whether we're talking about the actual semantics of the number that comes out of it. So there's something to be aware of because it's one of those impedance mismatches, like the word monitoring or logging, where different people mean different things. And this brings us to the question of, where is the timer type in a Prometheus client library? There isn't one. Because, well, timers are just a special case of tracking events, as an event size, which is how long it takes. So you got the summary and the histogram for that already. And what we do, rather than having a special timer, we just say, hey, here's a pile of utility methods to make it easier to work with times in summaries and histograms, because let's be honest, the vast majority of summaries and histograms are used for timing things. So here's a Python example. We just got a context manager there. The other languages have their own equivalents. Like was it try resources in Java we managed to get working? And in general, we all use seconds in Prometheus because you just need a standard. And how many people have looked at a graph in any monitoring system and you have no idea whether it's milliseconds or seconds? Yeah. So yeah, the Prometheus is seconds is the convention. Please put your metric name in anyway. And remember, no one's perfect until at one point, Prometheus itself was exporting 4 different time units. Nanoseconds, microseconds, milliseconds, and seconds. As of, I think, 2.3, we only have seconds. It only took 3 years to fix. But this is the sort of thing where it just causes confusion, and it's like, what unit's that again? Now, I haven't touched labels yet, which, let's be clear, are a killer feature of Prometheus. because of the analysis they allowed you to do. And they're key value pairs. And here we have an example. This is once again a Python example. It's got one label called path, and to use it, and that line on the monitors is really nice, we just go fails.labels/foo, and then your normal increment. One thing to be aware of, as you can see here, in the definition, I must provide my label names. The reason why is, well, if you don't know your label names in advance, you're probably doing event logging, because we're not working with arbitrary data that can change over time. We're working with metrics which have some structure and some continuity over time. And then we get to a little implementation detail. For whatever reason, whatever I was drinking at the time, it was probably tea, the return value of a labels call, or if you're using Go, it'll be the with label values, is the name of that method there. It's called a child, because it's, I forget why I called it that. And then internally, each metric then has a thread safe map that it looks these up in. And you know, if it doesn't exist, it'll create one, because normally you don't want to have to go and have a separate call and have it do like 4 lines of code, catching an exception to create it. It does it for you. It is safe to cache these child objects, and in some cases, you know, as I said previously, you don't want to look up by metric name every time. In the same way, you don't want to look up by label value every time, which isn't always possible, but sometimes it is. Like, let's say you had a Kafka client that was talking to one topic, and your metrics are written out by topic. Well, your Kafka object already knows the name of the topic, so it can then just say, hey, I'm going to cache all the metrics, all the childs for that topic, and then it's a free lookup. If you've got a HTTP router, well, your paths are going to vary all the time, and you can't do that. And remember, the goal here is to avoid potentially a lookup in a map, so there's no point creating a map, because that's what we were trying to avoid. You just have to take that 3 nanosegmentation. And then the childs in general, like in principle, in the ideal world, where everything's rainbows and unicorns, we would assure that every time series you care about, it starts to exist when the process starts, and it continues to exist until the process terminates. That's our ideal world. Because metrics that never exist or only exist sometimes are really, really annoying to deal with. So in the case of, well, Python client, you should just, at your definition time, if there's certain labels you know exist, tell us they exist. The reason why is, let's say that you had, and this is not recommended for among this reason, a counter broken out by successes and failures. And you were calculating your failure ratio for an alert. So that's failures over successes plus failures. If you have no successes, the child for successes will never exist. And empty vector and failures produces empty vector. Failures divided by empty vector is empty vector. If you put an empty vector into an alerting rule, you get no alerts. So you can imagine other ways that can happen, like that's a worst case, but you kind of want to make sure there's at least one child in there, so at least something's there. And there is also to mention, there is a remove method as well. You can actually get rid of childs. I've come across 2 valid use cases for this ever. One of them was presented here last year, but generally only ever use that for unit tests. Now, we're talking about all these objects that we have, and let's be honest, I have a gauge and a counter sitting in memory. That's not particularly useful. I want to get that data into Prometheus somehow, and then so I can get pages and so on and get paid. The exact details vary by library, but there's generally something called a registry, or in Java it's called a collector registry, because I wasn't being consistent that day, unfortunately. And registries do a pile of sanity checks, and they hold all these metrics objects. All these counters and gauges are registered in there, which is why it's called a registry. And there's also a note from a responsibility standpoint, registries do not produce the expedition format. Instead, what they do is they just have a list of stuff, and you say, hey, give me all your metrics, and it gives them out in some internal representation. And then you can do things with that. And I was mentioning the word collector there, and I'm not going to explain what a collector actually is, because you really shouldn't use words before defining them. Because all counters, summaries, gauges, and so on, those are a type of collector that return one metric. And they're nice and simple. But you can also have the custom collectors, which is just a terminology, and they can return as many things as they like. And they do things that you just cannot do with direct instrumentation, which is basically proxying data from other instrumentation and monitoring systems. And this entire system is all meant to be callback based, because, well, Prometheus comes in and scrapes, we fetch the data, do all the callbacks, marshal it all up, and send it back to Prometheus. So one example of a collector, a custom collector, is the standard exports. which I really should have named the standard collectors, but oh well, that was several years ago. So if you would notice, pretty much any Prometheus binary, or Prometheus instrumented binary, if it is running on Linux anyway, will have a metric called process CPU seconds total. Now you remember, about 15 slides and 20 years ago, I mentioned that you should never have the same metric name coming from two different pieces of code. But some of these are coming from the Java client, from the Go client, from the Python client, the Ruby client. And the reason why you cannot have things sharing the same metric name with different code is because they have subtly different semantics. In the case of these process underscore metrics, basically there is a standard defined that these have these exact meanings that on a Unix system. So then anyone using these names has to follow these exact semantics. So that's how those work. And client libraries also normally have stuff like what version of Go you used, and what version of the JVM, and so on, plus garbage collection. Now, there is a default registry that normally, if you create a metric, depending on the client library, because different languages are different, and you register into that, all happens up by magic. You can use a custom registry if you need something more special. You pretty much have to use that with the push gateway. And, well, let's be honest. A default global registry is global mutable state. And global mutable state has been abused horrendously over the last several decades, like since before I was born. So there are people who say, this is global mutable state, therefore it is automatically bad. I'd say don't say that. If you don't like this design, that's fine. You can use your custom registries and pass them all the way through, but be aware there are pros and cons. Don't just slate design just because, well, other people have similar designs that were a bad idea. And well, we actually need the output. So, it's the HTTP request. We take it in, we get the metrics, and we render the output. And as I mentioned, this is a public API of the registry. This is no private internal interface. So you can do whatever you want with this. If you don't want to send it out to Prometheus, you could marshal it into OpenMetrics. Or you could send it to Graphite, which we have examples for. Because in general, Prometheus clients are not trying to lock you in. I really like personally that we had like Sysdig on earlier talking about how it saves them so much effort having to write all these exporters, and that's wonderful. Because with all these monitoring systems, both closed and open, let's compete on interesting things, not who is the best stamp collection. Now, Prometheus is very opinionated, and there are things that client libraries explicitly do not do because they don't make sense. So for example, setting a metric name prefix on all your exposed metrics or adding a label to all exposed metrics, well, in Prometheus terms, that's called a target label, which you should do with relabeling on the Prometheus side, so client libraries don't do that. You can't vary label names in a metric because that's something for event logging. Being able to set a counter does not make sense. You only increment it. You want a custom collector. Pushing regularly to the push gateway. Prometheus is a pull-based system. Don't try that. And setting a timestamp on direct instrumentation. Generally, there are cases for using timestamps. You shouldn't generally be doing it. You're probably looking for a push system or not setting a timestamp. To look a bit towards the future, so we already had a talk about OpenMetrics, and with it, over the last 3-ish years, there have been some patterns that have appeared in Prometheus, and we're basically now making them first class within the client libraries. Basically, ways of dealing with strings, which are the info metrics, like Prometheus build info you might be familiar with, and enums, so these are also there. There's also a gauge histogram, which has come up like 3 times. I might have seen a 4th in one of the slides. But this is basically going to be a transparent change. You will not notice the difference. Someday you'll upgrade your client libraries and Prometheus, and they'll start talking OpenMetrics, and you will not notice. Except, the one difference that you're actually all likely to notice, if you have counters that are currently missing their underscore total, that's going to be there now. So that's the only breaking change that's really going to affect people. There's reasons we need to do this, but otherwise this is going to be a transparent change, and everyone will be happy. So here I have links, and if anyone has questions. 18 minutes, wonderful. First time I ran this talk took 22 minutes. Second one was 20 minutes. This took 18. That was me trying to speak slowly.
Hi. You mentioned that internally all client libraries have their histogram saved in a non-cumulative fashion, except for the Ruby one. Out of curiosity, why?
Well, the Ruby client has no locking at the moment, and that's just the way it's implemented. It just increments all the buckets. Yeah, the Ruby client, it needs to be reworked at some point. Like the Java client all got rewritten as well, like probably 3.5 years ago by me, because it just needs to be updated for the future at the time. But it's just something that confuses people regularly.
Hi, thanks for the talk. You mentioned that we shouldn't be adding base labels to things like that's considered kind of an anti-pattern. But this is kind of the examples that you've given work in a shared memory sort of process. But when you have something like a forking server and you don't have shared memory between them, what's your advice for kind of aggregating those metrics and exposing them from all the individual processes?
Yeah. So this is a So this is a complex problem because Prometheus is designed for a model where your language is multi-threaded and we can share memory. And then you get things like unicorn and so on. So the solution that I've proposed over in Python is basically every process ends up with an mmapped file that we then kind of merge together at scrape time. Because one of the things you don't want to do is, at least in my opinion, is you want similar performance to doing the threaded model, which means you can't call out to the kernel to send network packets, which means you can't lock via, kernel primitives. So that's what I ended up doing for that approach, which has its upsides, it has its downsides. Because I want instrumentation to be cheap.
Yeah, I've found a couple of different techniques, but yeah, mmap files. That's how we do it for our unicorn library.
Yeah. You're going to give those changes to Ruby as well, right?
Okay, my question is, what's the most exotic technology language you have seen client library?
One of my customers wrote a client library in TCL.
You got another question?
Is the file memory mapping implemented in the Python client directly? Could that be used from there directly?
Yeah, so Python itself has an mmap fault. So yeah, it's implemented, has been for like a year and a half or something.
Yeah, my company, GitLab, we implemented an mmap for the Ruby library as well. But there's also, I was looking into some other techniques, like some people use like a little agent binary so that you do a local memory push or pushing over a Unix socket. There's also POSIX shared memory segments that's possible to use.
Yeah, I haven't seen anyone trying that. I should mention as well that the work to do the mmap stuff in Python was funded by GitLab.
Cool.
Say thanks for that, Ben.
GitHub or GitLab?
GitLab.
Ah,
I
okay.
don't think you were employed by them yet.
I don't know. I wasn't. I didn't work there when they did that. More questions? All right. We got a break, and we'll be back at 1:30. No, 3:30.
Right. Yeah. So also, is there any diversity attendee who has not gotten the book yet? One. Otherwise, there are some books here that I'm giving out. I have the final 6 books, so if you come up, whoever's first.
Oh yeah. Do you have it? Do we have? We'll do it. We'll do it. Come up with some PromQL quiz questions, and we'll do it at the. We'll do it when we come back from break. Oh, okay. Go for it. We still got like 5 minutes before break start. Spotted something last year I didn't know. Just like, why would you ever add that? Let's see. First one. What is the limited number of points that a query range can return? Gusum, you're not allowed to apply. Tom, you're not allowed.
Yeah. It was mentioned, so it's a fair question. You already got a book.
11,000?
11,000.
Yay.
The reason why that's there, so need to sign it still, is I messed up once, and I managed to get it once per second from the Unix epoch to that day, and that killed Prometheus. So I thought, what number is large enough that no one should ever hit it? And our resolution for a week sounds pretty good to me. And that's like 10,000 and a bit, so it's like 11,000. That's where the number comes from. For now, we'll fix that. Sorry, where's that gone? Once again, Richie, not a medical professional. Okay. I remember some Docker thing years ago. I came up with weird questions. Name the 3 ways you can access PromQL.
Ooh.
Because there are 3. Yeah, contexts in which you can run PromQL. So one of them is the HTTP API. What are the other 2? No, Gautam. No, the HTTP API is 1. Yeah. Rule evaluations is 1. You already have a book. What is the other one? You just said that. The 3rd way you can run. So we have the HTTP API. We have recording rules. Yeah. You already got a book. Yeah, the summaries in the rules. Okay, I'll give you that. Console templates, which is the same code both in alerting and recording rule annotations and in actual, console templates. Console templates was the first feature I added. Do we need to go, or do I need to take up more questions?
Nope, it's time to go on break. We have 20 minutes.